Good morning, everybody. I am Easwaran Subramanian, Sub. I'm a research professor at Carnegie Mellon. Collective for Reimagining Engineering Innovation is a series of lectures some of us have started, a group of us, and this is the second lecture in this series. Our hope is to create a forum for debate on the nature of engineering, innovation, and also to understand what direction engineering should be going. We will have perspectives from people from around the world, and hopefully we will have other activities going into the future. This is the second lecture, and it will be given by Professor PVM Rao of IIT Delhi. He is Dean of Alumni Relationships, and he's founder of AssistTech Lab, assistive technologies they have produced for a number of contexts, including the blind and other disabilities. And he's the founder of the Department of Design at IIT Delhi. I could go on his achievements, including global awareness of assistive technologies through a number of global fora. Thank you, PVM. It's all yours.
Thanks for the introduction. And I think as Sub mentioned, as a part of this series, we are actually discussing some of the key aspects of engineering education. And we all know that there are too many challenges in engineering education at present, particularly in India, if not the entire world. And I think these series of lectures and interactions is probably more to exchange our views and probably see if we can be benefited by each other's experiences. And what I'm going to do is to basically share some of the experiments which we did it as a part of academic curricula. And I'm sure each one of you would have done the similar experiments. And what I'll do is I'll just take a few minutes to give a glimpse of that. And then we can have an interaction session of question and answers. So I've just put this topic slightly differently. But I think let me start with this one, which actually kind of exposes some of the gaps which we have in engineering education. Imagine that I want to do a 1-week certificate course on cricket. I think cricket is a game which most of you know. I'm assuming even Frido and others would know. So let's say I want to do this teaching of cricket as a 6-day course where every day there are a few lectures and discussions which are going to happen. On first day, I'll discuss about the game, and second day, I'll discuss about a little bit about match structure, rules, innings, and so on for 6 days, covering all aspects of the game of cricket. And on 7th day, I take an exam of 150 minutes to know whether you have learned cricket. But this is like one extreme view of learning cricket, where probably we don't go to field, we don't go to touch any of the cricket equipment and do it as a lectures and examination to learn the cricket. I'm sure it doesn't make sense to most of us. But if I take the extreme view of engineering education, it somewhat takes this form, where we discuss a lot about engineering in classrooms and do a lot of examinations, but in many situations, rarely get the real feel and experience of the engineering. And I think that's a very key to engineering education. So this is one extreme view I presented through an example of a game of cricket. There can be another way to look at, let's say I want to do a workshop on radio controlled glider making. And I would say this is a day-long workshop where I'll give you all the equipment which are needed to make a glider, all the, let's say, mechanical and electrical and controller which are required. And then I'll also tell you, or let's say the tutor will take you through step-by-step process of how to assemble a glider, and then probably take this particular glider to a field and then actually test the glider to get a feel of that. This is, in doing so, probably you are able to build a glider and probably test it. But I'm not going to discuss anything about physics of flight. I'm not going to discuss anything about control, stability, or any of the fundamental aspects of physics of flight. Is the other extreme point of view, where you get a experiential view in a limited sense, but at the same time, you are not connected through a theory, which is the other extreme, which is possible. And I think engineering education is neither, and I think it's probably requires both, but I think much more than that. So in other words, theory and practice go hand in hand, and a lot of reflection which happens from one to another when you switch. And I think that reflection is very, very important component to learn the engineering. So if I take maybe a better analogy for, let's say, an engineering education, that would be like probably, let's say, mining to find a gold. Now, the process which I follow is that I study geology and other mining related subjects from an expert, and then I plan for mining. So there is a planning aspect. Then I dig, and then I overcome a lot of problems and obstacles like boulders, waters, gases, trapping, and I learn to overcome these obstacles. And maybe after a few iterations, I find a gold. Now, this is probably is a view which is very different from the first two views which I covered. Here, I think each step is an important. So understanding the theory in the form of geology is important. And then there is a planning aspect. And then there is a digging. And I think each of them relates to the theory, and you have to do back and forth. And then probably one finds a goal. So in other words, it's not either or theory or practice, but it's like both of them with a lot of iterations and a lot of couplings, and through a lot of reflection, which one learns. Now, this is the kind of view which we took, the finding the gold through mining as a probably analogy in some of our early courses when we introduced new curriculum about 10 years back. And one of the things which we did with a lot of students, some probably at least about 10,000 students in last 10, 12 years, is one of the exercise of making a glider, but I think in a very different way. This is not a RC glider. This is a simple mechanical glider. So where we actually teach physics of flight for, let's say, an hour. And then we ask them to use that particular theory to design a glider. So there is a design phase. And then you have to realize your design in the form of a glider. So there is a build phase. And then there is a testing phase where you actually test your glider about its performance. Now, this type of exercises which we found are extremely, popular with students. Because and we do this when the students come very early in the engineering, the very first semester, in a very one day a workshop, they actually get to at least learn a lot of things. First thing is why science is important for, let's say, building a product such as glider, and how does design plays a role in the performance of a glider, and how does, let's say, realizing design in the form of manufacturing and having the right form and tolerances helps in terms of the performance. And in case of successes and failures, how the science, design, and you can say prototyping helps in this particular thing. People get a very early experience of these relationships. And we have seen that these are pretty well taken. Like, as I said, we do a 1 hour lecture, and then we have hundreds of people who actually work in teams to build this glider, and then they actually test these gliders. And as I said, it's basically not theory, not practice, but it's a very combination of theory and experience, and a lot of reflection to know a very first experience of building a simple product is something which is there. And in such courses, what we have seen is that you don't have to take attendance, you don't have to conduct any examinations. And these type of courses, we never had any problem somebody skipping, let's say, a glider making workshop because they didn't enjoy or this thing. So in other words, many of the things which we do in a routine classroom also become a redundant, which we realized after a few years. Now, taking that as one of the just examples, we looked at the curriculum about 10 years back, and also asked a lot of students who graduated and the current students. Because as you know, I don't know, maybe many of you may have experienced right now, when it comes to an engineering education, there are some serious challenges, both from the faculty who are excited to go to a classroom, to students who are also not equally excited to go to a classroom to learn, how to probably make it a little bit more, I would say, enjoyable and a wonderful experience for both. We asked students, why is that many of the students probably prefer to stay away from classes? Particularly, this is true not only in institutes such as ours, IITs, but it's across the nation. Then they came up and said a few things. One thing they said is, education is dominated by lectures and examinations. And we don't see a strong connection between our education and the real world. This is a second point which came strongly. And the third thing is that they came to engineering with certain aspirations. And what they're learning and how these aspirations would be met was not very clear. And even when engineering courses had a practical component, they said that these practical components are very procedural. Procedural in the sense, an experiment is designed and you can't actually, you have to follow a specific protocol. Everything is fixed. You know what is the kind of results you are going to get. And if you are right, all of you should have the same type of experimental results if the experiment is same. But what they wanted is a little bit more cognitive and creative component in such experiments, which was seriously lacking. And they said a lot of engineering education, particularly in India, is all about head. There is very little scope for hand and heart, which is an important aspect. And there is too much emphasis on knowledge acquisition than applying this particular knowledge. So taking these very important feedback from students, we realize that there are three major aspects which needs to be corrected in engineering education. And first one is more about experiential learning. They were hungry for learning by doing, And I think when we did some of the experiments, we found that they really love the experiential learning aspect of the engineering is one. And there are not many courses where they get to work in teams. So they wanted to also have an experience of collaborative learning, because once they graduate and go to industry, most of them have to work in teams. And if you did not have any prior experience of working in teams, then you take long time to adjust to the new environment. But if you had some prior experience, then it greatly helps you to probably get into your new role very easily. And all of them wanted some collaborative exercises throughout their 4 years or 5 years of stay. And this is the second thing came. And the third thing which also came is they wanted to connect with the real world. How is that engineering is applied? What are the real world challenges of engineering? And what has that to do with what I'm learning, etc. And this also we experimented taking students to fields and showing them the real world problems and asking them to see if they can actually get a feel of it and even address some of these problems. So these three things, the experiential learning, collaborative learning, and social learning, was came in a very big way when we discussed with most of the students. And with that in mind, we actually designed a few courses. So one of the courses which we did was on a product realization. So this is a course which every student has to take in the very first year, and where you have to build a product. It has an experiential learning because you have to build a product. And these are all done in a teams of a few students. So there is a collaborative learning. And what they build is not told to the students. Students have to choose their own products or the pain points of either their family or their society or their city to build something which interests them. So it had all the three components. And when we introduced, now we have again like about 10,000 students have gone through this course. And the experience has been really wonderful. We did not expect when we introduced, but I think it came out very well. So one thing is it's a team-based product building course, and it gives them very early experience of product building, and they have flexibility. And I think this is very important in many of the engineering curricula. The teachers actually design the problems to be solved for which solutions are known. But I think if you give a freedom for students to choose their own problems and their own solutions, we have seen that it wonderfully works. There is a strong ownership, and then there is a ego comes to play, and that's very interesting. And the role of teacher is probably little compared to many of the courses, and to facilitate and excite students about that, and also help them to do similar activities, rest of them. So this was a course which was introduced in the first year, and it's a mandatory course for every undergraduate student in engineering there. And we started a similar course where with more of field experience and the real world experience in the third year, which is called Inclusive Innovation, which is actually an elective course. And this particular course is to basically for students to go through a very systematic innovation process through design thinking, and identify a problem or a need, and validate this particular problem before you sit for a solution through all the stakeholders and a lot of field work and a lot of primary and secondary research, and then co-creating solutions with all the users and stakeholders, and then validating the solution. And the whole idea was that it was also a thematic course where innovation process is specifically applied with the inclusion as a dimension. And this we are now running, I think, the 8th edition of this particular course. And it actually gave a very different experience to student. They were saying we were all dealing with how to solve, let's say, a differential equation, and most of the training went for basically related to the brain, but I think this course gave them both the hand as well as heart, because it's hard because they could actually, many of the students could see for the first time what are the real world problem and what are the challenges, and exposed to them. Like, for example, a typical problems would be like one of the groups was working on, can technology help better sleeping options for rickshawalas, which Delhi has in thousands, to something like, can technology provide an improved housing for construction workers, which often they live in very risky and not so happy place to live in. And students generally come up with their own designs, and then they even build, demonstrate, test, and that gives them the actually going through, at least attempting to solve a real world problem in a limited time. Like this is another group which was actually working on how to basically reduce the pain points of people who are working in handloom industry. And students again go through a design process, because this is a third-year course where they are introduced to engineering. They even go and build a prototype at the place and demonstrate that the solution is working, or in other words, it's a validated kind of a thing. So the idea of bringing these examples is that we have seen when you actually provide these type of experiences, students are generally much more excited. And instead of pushing them to classrooms, many of them took these courses voluntarily and did very well. And it also helped us to do. So our what has worked for in a curriculum is typically a journey of when they come, you try to introduce courses which gives them an experience of a maker. At some stage, you do an innovator. And some of these people probably end up taking an entrepreneurship, which also happened in a fairly big way when we look back for the last 10 years of work. So in fact, we have a lab which Sub has introduced, which is called as an assistive technology course. And some of these students who went through a similar process and end up spending many years in assistive technology lab, actually building the products and taking to people. And I'm showing some of the students who not only graduated, but actually stayed beyond their graduation, leaving their placements to take their design and innovations to the people. In other words, they gave some of their very valuable years to the lab because they loved doing things. And they were also introduced to innovation courses in third and final year. Some students stayed for a couple of years, to somebody who stayed for 8 years with us after the graduation to take products to people. So that is we consider as one of the success. A similar experiment was also done where we ran a program with All India Institute of Medical Sciences, which is a major hospital located in Delhi. And we had a program where we always had an interdisciplinary team of 4 people. One of them has to be a physician, second has to be a designer, third has to be an engineering guy, and the fourth one, somebody who understands business and somewhat real world experiences. And they are put together to go through this fellowship of 1 or 2 years to invent medical devices. And what we have seen is that in about 10 to 12 years, they came up with many devices, more than 50 devices, and many of them actually went to market or ended up as a technology transfer to a bigger companies. But the whole idea of here is that giving freedom to people to do what they want and introduce them to very early to the process of making an innovation helped very largely in these processes. So when I look at and somebody says, I'm an engineer, that's what 10,000 engineering colleges in India produce engineering students through 4-year programs. When somebody says an engineer, we have a whole variety of people, a small percentage who went through real engineering experience to a large number who probably did not have that particular opportunity. So we tell our students ki engineering is a noun, which all of you know, but I think it's more as a verb. When somebody says, I engineered certain things, that means there is a strong verb which is associated. Often we don't introduce engineering as a verb in our curricula, but I think if we can do that, the results have been really wonderful in this thing. So I would probably end my this thing by saying ki, we start looking at engineering as a noun, but there is a lot of doing aspect, which is a verb. But I think ultimately, when you spend enough time doing engineering, an engineering becomes an adjective. In other words, you say, here is a person with engineering mindset. And I think that's the probably a goal which most of us would like to have. So what I did is I just introduced just to trigger the discussion, and I'm actually really looking forward to more of the discussion on this particular subject. And thanks for this opportunity, and I'm open to questions.
Let me ask PVM this whole process you went through in terms of engaging the students. Were you able to sense from the beginning that somehow there was a certain yearning in them that was not getting fulfilled, and did you sense that and was able to create a dialogue with them to create the kind of programs you created?
That's true. So what was happening is when I think we found when we taught such courses, our realization was same. We found that students were always hungry. We never realized that this is the way to go for many years. Of course, we did have a little of this, but they probably looked at much more rigor in experiential and collaborative learning, etc. So that was our first realization. But we also found that when students were not getting similar experiences through curricula, they also found other alternative ways to get the same experience. So, for example, many of the engineering colleges which still do have these engineering clubs, automobile clubs to robotics club to clubs on genetic engineering, where they do these type of activities as a co-curricular activities, where they make their own teams, they identify their own problems, they find their own resources, and then find the solutions. So we found that in those situations, students were the students were not asked to do it, but I think they were voluntarily doing it, spending hours, days, and nights in these labs. So that also gave us enough experience that what they were doing is actually not very different from engineering. But why is it not a part of a curricula? Was also a realization which we had.
There are a few questions, and the first one, Kumar Reddy, I will open your mic. Please unmute. Oh, can you come in? Are you able to unmute yourself?
Yes, sir. Unmute.
Yeah, one at a time, please.
Yes, sir.
Mr. Kumar Reddy, go ahead.
Yes, sir. Thank you very much, sir. So, I'm the assistant professor.
Keep your questions brief. Yeah, go ahead.
So the focusing on the curriculum, the present situation regarding the about global warming, sir. It's a very helpful the point of thermal engineering, sir.
Yeah. So, okay. So what you are saying is there similar courses which relate to climate sustainability or global warming? Is that what you are saying?
Yes,
Yeah.
sir.
So I think there is no specific course which is project based, but there are a lot of courses. But many students, both bachelors and masters, end up doing projects in this particular space. So I think there is, I think every university would now have a program on climate, sustainability, and energy. And I know a lot of projects are done, but we did not start any specific course which is experiential in this. But we may have had some of the competition for students in this space with other organizations.
So the next person, Basavaraj, I will please unmute. Go ahead and ask the question, please.
Good evening, sir.
Yes.
Yeah, I'm Basavaraj Madigond, chairman of the Board of Studies for Electrical Engineering of Vishweshwara Technological University.
Wonderful.
Thank you for your wonderful insight, sir. Now, the major challenge in what we are facing here is to how to create a curiosity or interest in the classroom. And you have opened up a wonderful thing, sir. Now we are reframing the syllabus for undergraduate level for Vishweshwara Technological University of Karnataka, sir.
Yeah.
As you said, that product-based learning and how to incorporate these things into the syllabus. So what we are facing, generally what we face is the time constraint. We have to complete within 4 years and so many courses and create a curiosity in the students.
Yes.
That is what I just would like to have your, advice, sir.
Yeah, no, I think your question is wonderful. And I think the challenges which you told are faced by not only you, but I think many other technical universities with whom we discussed, including AICTE. Okay. Okay. So what happens is generally when you design a curriculum, it's not possible to do a major overhauling with most of the courses taking this type of a shape. But imagine that even if you're able to introduce one course per semester or a year would be a good beginning, so that you're not actually disturbing a lot of other things, because it's another very important thing, which is also is that as far as students are concerned, you don't have to worry whether they will be able to do or whether they'll be able to take interest. But I think when it comes to faculty, when you do your, let's say, syllabus revision and introduce a couple of these courses, it's good to train at least a couple of faculty from each of the institutes in this particular aspect, or at least identify who are already doing this particular one, which is important. Generally, what happens is it's also important that the faculty who is doing these courses also have a strong passion and ownership to do experiential and social learning. If you're able to identify a couple of them or train them or orient them, it's a very interesting and it's possible to implement. But yeah, in terms of time, I'll also say, if you really look at the undergraduate education, as every branch is spreading their wings, it's not possible to make a specialist in 4 years of undergraduate. So a lot of universities are now looking at broad-based education for engineering and actually pushing the specializations to master's level, which is there. There was a time, maybe 30, 40 years back, when you had to learn all that which you call as a mechanical engineer to graduate, but it's not possible in today's this thing. So people get a feel of electrical mechanical engineering and some experience as a part of a bachelor's, but get actual specialization when they do either projects or go to master level to do that. So I think we don't have to do the same things which we're doing for many decades, and probably move slightly away from that. And very recently, you can also look at IIT has also done this thing. So they have come up with new curricula for mechanical engineering, electrical, computer science, and other branches. And they have also been now able to introduce some courses of this nature so that students get this type of experiential learning.
PVM, there is a question in the chat. How can technical societies and industry association help in advancing and catalyzing practice-based curriculums in the engineering institution, given the current scenario? This is from Madhukar Sharma.
Yeah, Madhukar, thanks for this question. And I think when I look at one you mentioned about the like, for example, if I really look at the industry perspective, industry would definitely value such an experience from a student. And we have also seen the students who spend more courses on such subjects were extremely valued by an industry. And like even the students who ended up staying for an additional year or two with us are most sought after, not only by the best companies, but they're also sought after by some of the best universities for higher studies. So a lot of these people, like some of the students from assistive technology, they had a very easy opportunities in even global companies such as Tesla, Apple, to do the product building careers, etc. And coming to the professional societies, I'm sure professional societies do value, because they do have people both from academics and industry and people who have done similar experiences. So I don't think anybody would not like to have such courses, but the only thing is when to do it and how fast to do it is an issue.
There is another question from Professor Gangadharan. What is the percentage of success in these projects?
Okay, very interesting question. So if you really look at how do you measure a success in such projects is very different. For example, when you're doing a first year course, it's all about learning. If they come back for more such courses and similar, if they start taking more interest in engineering, your mission is accomplished. And even when the students do such projects in third year and fourth year, it's not necessary that these projects actually, all of them end up as a market ready product. That's not going to happen. In some small cases, it happens. We did have few successes in that. But the whole objective of training them is to basically train them in the innovation process. So I would say a good measure is, for example, when we did inclusive innovation courses, if you ask me, are there any products which have actually hit the market? There are very, very few. But what I measure as a success there is about 15 to 20% of the students chose to go to organizations which basically chose to join social enterprises rather than a big corporates because of their experiences, etc. So that also we consider as a success. But this is an early failure, an early experience to fail, so that next time when you take up, you are well prepared for your success. So it's not necessary. We never measured many of the course outcomes as products which should reach, but many of them end up become entrepreneurs and product builders in near future. And I think that we look at as a success.
Any further questions? I have one. Maybe this will trigger some other questions. Institutionally, you talked about how you can introduce these things in a slow and systematic way. The thing I wanted to ask was, you also talked about the idea that outside the classroom there was a set of places or open spaces, workspaces, if I may say so, that also triggered the kind of interest and extracurricular activity which led to people appreciating this kind of teaching and work as far as the students were concerned. Is that correct assessment?
It's a correct assessment, and it also relates to Mr. Basavara's question.
Mm-hmm.
What happens is when we did not have these type of courses, a small percentage of students still used to go to maker spaces and clubs and do some of these experiential product building activities. But they were also burdened with the curricula, as Mr. Basavara said. You have to do 6 courses, and this is your extra work which you are supposed to do. Now, what we have done is, we said ki this is not an extra work, it's a part of your curricula. So instead of, let's say, doing 6 courses plus your co-curricular activities, now you do 5 courses and maybe a 1 course of this nature, so that it becomes a very integral part of. So all that which we did in last 10 years is to see that the interest which students take in co-curricular activities, can I make it as a curricular activity? Mm-hmm. And I think that has worked, because people now don't have to complain that they don't have enough time to do, because it's taken from the same time and made it more formally integrated with the curriculum.
Yeah, very interesting. So, okay. The next question is from Srinivasa Kumar Reddy. Focus on experimental learning. How many of the engineers graduated with complete knowledge mean practical, not book knowledge? I didn't get the whole question. I think he's asking how many people graduated with a broader knowledge than just book knowledge, do you think?
Yeah. So what happens is many of them. So when you say book knowledge, that's also very essential. And what happens is what we have seen is suppose, let's say somebody has not learned a theory, and probably they get into more of an experiential learning, but it also triggers I think a lot of I would say curiosity to go back and look at fundamentals. I'll just give an example. We had one of the first year students who was asked to build the very first product as a double pendulum. And this student actually did a good job. And when he actually demonstrated this pendulum, always, in a double pendulum, you also have a chaos. And I think people would ask him, whomever he demonstrated, why is it behaving in a very chaotic way in certain situations? Now, this actually triggered him to go back and look at the theory and derive the equations, which also happens. In other words, when certain things which people experience in a real world, they would like to go back and look from the theory point of view, why there are certain things behave in a certain manner. So theory and practice, we don't look at as separate. Theory provokes you to probably look at, you get the same experience through experientially, and experiential learning triggers you to go back and probably look at theory again. And this is like a cycle. And if somebody is able to get into this cycle, and I think our mission is accomplished, and they walk away as a better engineers. And coming to your question, there is nothing like a complete engineering knowledge which is possible in 4 years. So everybody walks away with certain experiences, but they have a confidence to learn more. And given a new situation, they'll be confident to probably learn and do it. And I think that's also an important. It's very difficult to give a large, broader, diverse experience of engineering again in one degree. So, but I think you go through certain experiences, but this gives you enough confidence to try new ones when you are encountered with a problem.
There is a question from Frida Smulders from Dell. Regarding experiential learning, do you make use of the experiential learning model of David Kolb for developing the didactic structure?
We at least I am aware of that particular thing, and you will also see some similarities between what students do and this particular model. And I think you just mentioned one example. There are many such examples, and one can very easily relate once you get into experiential learning component. We did have many of these things looked at, both by students as well as faculty who taught these courses.
Go ahead and unmute yourself and ask the question if you have. Srinivas, unmute yourself. Yeah.
Sir?
Yeah, please go ahead.
Sir, it's a nice explanation, sir. But one request, sir. Generally, who are graduated as an engineer, they simply focus after their 10th or SSC, whatever it is. Some states are SSC or 10th. If focus on diploma, sir, diploma come graduation is good learning, sir. My viewpoint of some states are encouraging diploma, and after the diploma, engineering graduation.
Yeah.
The graduated with experimental knowledge, sir, after graduation.
Yeah. So I think your observation is right to some extent, because if you really look at the curricula for diploma, it is little bit more hands-on than the theory. So if student actually comes with some of that experience,
Yes,
and
yes,
goes through theory, we have seen in some cases students doing extremely well. But there are also another set of students who actually come to engineering from diploma to basically probably not to gain the same type of engineering experience, but to probably have a better opportunities. So we have both the people who use their previous knowledge of diploma and build on that, and they do very well even in bachelors of engineering. But then there are some who probably relinquish, or you can say doesn't give much of their prior experience and would like to get into the rat race of engineering, which we see these days. So we have seen both the cases. Your observation is right, actually.
Thank you for the questions. Any other questions? Sarbajit Singh, yeah. Please go ahead and unmute yourself.
Thank you. I am not from the academic field, but I've been introduced this, and I was very nice to have heard this talk. I have something to say, and I don't know, for your consideration.
Sure.
I have a grandson who's studying IB, International Baccalaureate course.
Mm.
And there they have a program called Design and Technology.
Mm.
They are required to think of anything they want to do, design it, and go into the lab and actually make it. And then they try it out. And if it doesn't work, they're told the principles, and they use those principles to make it. And if it doesn't work, that's not a problem. What they ask them is, okay, what went wrong? Why didn't it work? And they have to analyze that look, this is what the mistakes I made, and this is what has to be done, and then go back and try to set it right. And they even try to encourage them to work it into a business model, if they can want to make it into a business. And I've seen that him doing it and even actually making some money out of it. So I thought this was what is there at the school level in the IB. Don't you think we need to bring in something like this in Indian education? And it would help in doing what you are doing further?
Yeah. So, Mr. Sarabjit, I think a very important insight and question. I think what you mentioned is key. It's not the success, it's the failures which teach you more. And I think that's a very important for somebody who is evaluating such courses. So if somebody has really gone through a wonderful experience, but product is not successful, still ends up getting the same appreciation and maybe a grade compared to somebody who has built a product which is working, but may not have gone through the same rigor of experience. So I think that's I think what you said is very important for the faculty when they sit for evaluation. Are you looking at the outcome as a product, or are you looking at the outcome as a experience of going through an engineering process or an experience? Is a very, very important. And I think we do that all the time. The second is the business models, etc. Are also this thing. We do have, I didn't cover all the courses. We do have few courses which link product design, product building with entrepreneurship, which we do separately for those students who'd like to take some of their ideas. They have already built, let's say, a proof of concept, and now they would like to convert their proof of concept into maybe possibly a venture. So there are separate courses which we also do. And coming to your important point, whether it can be done, whether it should be done in the school education, I would still go ahead and say that it's badly needed. So I'm again sharing this thing just to show. We tried some of these experiments not only in our college, but in other engineering colleges and also in schools. So, for example, in fact, in the interest in school children is even much more than the graduate students. And I think their curiosity to learn engineering, build products, and even, as you said, to become entrepreneurs is much more. And I think we had a exactly same experience with large number of Atal tinkering labs, even schools which are not necessarily English medium schools. For example, this is a Hindi medium school in Delhi with very limited opportunities. But I think given an opportunity, they do wonders. So I think your suggestion is definitely something which is needs to be pursued at a scale to get the benefits.
Thank you. Thank you very much.
Even though I put it as 1 hour, 15 minutes, we keep it to an hour as much as possible. I'm going to announce the next lecture today, right now. It'll be by one of the colleagues who's online today, Frido Smulders from Technical University of Delft, Department of Product Design. The title is How to Educate the Entrepreneurial Engineer. The nouns, verbs, and adjectives. Frido decided to follow Jan to explain his work through the same lens. So we are delighted that so many of you have participated. The first video is already available as I put it on the web, and this video will be available in a couple of days because I need to do a little editing. And once that is done, the video will be available to everybody. You can go register at the CRE page so that we have your link so that we can send out future announcement. Thank you, PVM, for a lovely lecture. And thank you very much for all of you for attending this. Please get involved, connect with us. And if you want to talk about your own experiences, you're very much welcome. And we may also start another discussion forum later on. But for now, it'll be a series of lectures almost every 15 days. And the rest of the lectures will also be announced very soon. And there is a feedback form, and those of you who can fill the form and send it, we would be very grateful. Thank you all. Thank you, PVM. Thank you, everybody, for a lovely evening talk.
Thanks for the opportunity.
Bye.